On February 26, 2007, Mr. Willard's AP Environmental Science class made a trip to the Sugar Creek wastewater treatment facility here in Charlotte, North Carolina. When we arrived, we were greeted by Mr. Roy Ferguson, the facility supervisor, and he started out by giving us a general orientation to the facility. In this satellite image obtained by using Google Earth, you can see the main part of the facility, which sits just to the east of Little Sugar Creek and just to the west of the intersection of Tyvola and Park Roads. The first part of the process is called primary treatment. This is largely a mechanical process where solids are separated from the wastewater. Bar screens are large mechanical rakes that pull most of what people flush down a toilet out of the wastewater. Toilet paper, tampons, and condoms are all dumped onto a conveyor belt.
On three. Step back. 1, 2, 3.
These trash items are then carried down the conveyor belt and into a separate room. They'll fall out of a chute and into a trash can.
Oh yeah.
While it may look disgusting, these slowly degrading materials must be pulled out of the system and dumped in the landfill. The Sugar Creek facility handles mainly domestic waste, mostly from the uptown Charlotte area. If they receive too much volume, they can bypass it through massive underground pumps to the McAlpine treatment facility. Wastewater moves from the bar screen building to the odor scrubbers. Here, chemical compounds are combined with the wastewater to remove the substance that smells the most, hydrogen sulfide. Next, the wastewater moves into the pump houses, where 4 massive pumps send the water back up the hill to the primary clarifiers. The purpose of the primary clarifiers, or grit settling tanks, is to allow the solids in the wastewater to settle out. This forms a substance known as sludge. Here are the clarifiers from above. These structures are not clarifiers. These are old trickle filters that are no longer used at Sugar Creek. The sewage sludge that settles out in these tanks is not handled on site, rather is pumped across town to McAlpine's facility. At the McAlpine facility, the methane gas is burned off, the sludge is collected, and can be spread on fields that belong to the county. The second part of the wastewater treatment process is a biological one. This facility uses activated sludge tanks full of microbes to further digest any organic material left in the wastewater. Again, notice these are obsolete trickle filters that were once used for the same process. In these long tanks, oxygen is bubbled up through the wastewater, so aerobic microorganisms can continue to digest the remaining organic wastes. One appropriate title for Mr. Ferguson may be Microbe Farmer. Although the water has a brownish tint, it is relatively clean at this point. The next set of concrete containers, called secondary clarifiers, are used to collect the microbes and return them to the activated sludge tanks. Finally, the wastewater has to be run through charcoal in this long building, and then it has to be subjected to ultraviolet light. This is one way of killing any disease-causing microbes that may be left in the wastewater before it's discharged into the stream. Ultraviolet light systems disrupt the DNA and prevent the microbes from reproducing. These systems replace chlorine, a very dangerous chemical that has fallen out of use since 9/11. Once the water leaves the UV light array, it cascades down a dissolved oxygen ladder This is simply a large concrete structure that allows oxygen to be recirculated into the water. The Clean Water Act empowers the EPA to set enforceable standards for the amount of dissolved oxygen, nitrogen, phosphorus, and BOD that comes out of the plant at this discharge point. These two clowns are just hamming it up. The water that comes out of the plant at this point actually looks and smells relatively clean from when it entered. Down in the southwest corner of the facility, there's an overflow structure. This facility is not meant to treat stormwater, but so much stormwater infiltrates the sewage system on heavy rain events that they must have the capacity to store this excess wastewater on site.